Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. And in this video, we're working on that graphing linear functions, homework number one, numero uno. And in this video, we're going to be making sure that we can plot those points carefully on the graph. We're going to use those ordered pairs that we find from that input and output table, or that function table, plot them on the point, or excuse me, on the coordinate plane, and have what our domain and range is. And also too, I'll include a little bit of Desmos so that way you have an easier time of using that function table. So I did the first one in class already, but I'll do it again just because I want to make sure everybody's on the same page. So in that first one, it has our function is y equals 2x minus 3. And so again, I give you the x values already, and so that means you know what the domain is. And so our domain is always the x values, so it's -1, 0, 1, and 2. And so it's actually going to be all of those, or for each of those four problems that we have, it's going to be these four values for the domain. Again, all you have to do is plug in your x value into your rule. So again, for example, you would say, all right, I have 2 times the first input, which is -1, minus 3. And so again, I use my order operation, so I do 2 times -1 is -2, minus 3 is -5. So that creates the order pair -1, -5. I do that for the other points. Again, I plug in where x equals 0, so I have 2 times 0 is 0, minus 3 is -3. I plug in for x equals 1, so I have 2 times 1 is 2, minus 3 is -1, and then I have 2 times 2 is 4, minus 3 is 1. So now I have my y values, so that means I know what my range is. Again, usually I have my domain and range in order. Again, they don't have to be paired up. That's only when you have ordered pairs of one you have to have, your left and right sock. You have to have your x variable and your y variable. For domain and range, again, just have them from least to greatest, and just have the x values for domain and the y values for range. If you're having a little bit of difficulty, I saw some people using the handheld calculator, which I'm glad they're at least attempting it, so kudos to them. But if you want to make it a little bit easier, which you hopefully should, you can bust out that Desmos calculator, and you're saying this. I am going to have where my rule is now my expression. So I type in my expression exactly how it looks, and I say 2x minus 3. Again, since I need to define what my variable is, I have to hit a new line, so I press enter, and then let's say I want to find out when x equals -1. Again, this creates the ordered pair -1, -5. Again, you have to be careful though. Again, this on the bottom is our x value, and then the y value is on top. And so that means the ordered pair is -1, -5. Again, I can show that for the others. I can say for x equals 0, it's -3. For x equals 1, it's -1. And for x equals 2, it's +1. Again, you can choose whatever x value you want. So for example, if you picked 10, your y value would be 17. If you picked -20, your y value would be -43. So again, any of these ordered pairs would work, but you'd have to make sure you plot them carefully on the graph. Again, when you go to plot on the graph, it's going to look something like this. Again, I make those 4 ordered pairs, and then since I know that I am drawing a straight line, since I have a linear function, that means it is a straight line. I know I graphed my points correctly, and so I can draw the line through it and label it correctly. Same idea for the second one. Again, our domain is going to be the same, so it's -1, 0, 1, and 2. However, our rule is going to be -1 times our input plus 1. And so that means we have -1 times -1 is a +1. +1 plus 1 is 2. Again, you kind of follow these steps through for any of these values that you have. Again, these form the ordered pairs, and you can have the domain and range. Again, usually I have my domain or my input or my x values as blue, and I have my y values as red. So again, even though these look like the same numbers, your domain is the x values and your range is the y values. Again, to double check to see if those ordered pairs are correct, I can type in our rule. Again, we said our rule is, let me actually highlight it in green. Hopefully it's not too dark. No, it's perfect. We said our rule is that part in green. So we're saying all of this is our rule. And so when I go to type it in, I have to make sure it looks exactly how it does in the original function. So I have -x equal, or excuse me, a -x plus 1. So that's going to be my function, or excuse me, my rule. And so now I need to define what the variables are. So again, if I say x equals -1, our value should be 0. So let's actually, our value should be 2. There we go. So if x equals -1, our y value or our output is 2. And that checks off as we know that is correct. For the other ones, again, we had 0. So ordered pair is 0, 1. For our x value of 1, our y value is 0. And for the x value of 2, our y value is -1. So we know that we are on the right track. Again, you can choose the x value that you would like. I could choose 58 to get a value that I need. Again, as long as you are inputting a value into the function, you'll get an output. So let's kind of look to see what this looks like on the graph. Again, I plot the 4 ordered pairs that I have. Again, I have the ordered pairs -1, 2, 0, 1, 1, 0, and 2, -1. I plot those points out. Since I know it is supposed to be on a straight line, I know I am good. Again, I draw the line through the points the whole way down. Make sure you're using a ruler or straight edge. Maybe the back of the calculator is a good workaround for that. And make sure you can label it correctly. Moving on to the back, halfway done. This one's super simple, as you're only increasing it by 5. So whatever your x value is, you're now just increasing it by 5. So I have -1 plus 5 is 4, 0 plus 5 is 5, 1 plus 5 is 6, and 2 plus 5 is 7. So again, notice that pattern. It's the same rule each time. However, the x value is what is changing our y value. So again, our y value is dependent on our x value. So again, our domain is still the same. However, the range is 4, 5, 6, and 7. To show what it looks like on the graph, again, I have those 4 ordered pairs. I know they should be in a straight line, and I can also tell, hey, as my x values increase, what happens to my y values? They are also increasing, which makes sense as this is a positive slope. If we were doing a scatter plot, this would be a positive correlation. And for the last one, a little bit trickier, but we did an example in class just like this. Again, you can rewrite this as 0.5 times x, so that way it's a little bit easier to evaluate. Our domain is still the same, and so you could say, all right, 0.5x times -1 is going to be -0.5, and so then we take this is -0.5 plus 2 is 1.5. Again, I can use that Desmos calculator to check. So I can say 0.5 x, I said plus 2. I could also say I want to make the fraction. In the numerator, I have 1. In the denominator, I have 2, because that's 1/2. And I can say times x plus 2. Again, these are the same, so my values, whatever my output is it should be the same. So I'm saying if x equals -1, again, our output is going to be 1.5. So again, either of these would work. And so again, you choose what the x value is. However, I usually just do these 4 simple ones to keep it easier for ourselves. So now we have, and we are checking these inputs. So I'm saying if x equals 0, our output is 2. If x equals 1, our output is 2.5. And you guessed it, if x equals 2, y value is going to be 3. Be sure to plot the points on the graph carefully. Again, it's not as steep as an incline or as a slope as the last one, but it is still a positive slope. Again, plotted those 4 points in a straight line. We know we're good. We're moving on.